Welcome viewers, in this video we will see the flip-flop conversion SR flip-flop to D flip-flop, converting from SR flip-flop to D flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, conversion of SR flip-flop to D flip-flop. We know that flip-flop is the storage element. It will be able to store 1 bit data. So here we need to convert SR to D flip-flop. SR means set reset. We know that it's a very basic type of flip-flop. So we are going to convert SR flip-flop into D flip-flop. So first we need to see what is the D flip-flop input and output. That is truth table. So flip-flop, we know that the output we have two stages, present state, next state. Qn is the present state, Qn plus 1 is the next state. So the next state of output is depends upon present state output as well as input. Output is depends upon input as well as the present state. So these two will decide the next state of output. So the D input, we'll see the D input. There are two, now we have two inputs, D as well as Qn. So 4 combinations, 0, 0, 0, 1, 1, 0, 1, 1. D may be 0, Q1 also 0. D0, Qn may be 1. D1, Q1 will be 0. D is also 1, Q1 also 1. Right. What is the nature of the D flip-flop? What is the D input? That will be reflected as a next state of the flip-flop. D0 means Qn plus 1 also 0. D1 means Qn plus also 1. It will not bother about the present state. The next state is purely based on the D input. It will follow the D input. Input what we are giving, that is appear as the output of the flip-flop, that is next stage. Right. That is the nature of the D flip-flop. Now we need to decide what is the input to the SR flip-flop, because SR flip-flop we are going to convert into D flip-flop. By giving the proper input of SR flip-flop, that will convert it into D flip-flop. That is 0, 0. Present state is 0, next state is also 0, mean what is the input to the SR flip-flop. Similarly 1, 0, 0, 1, 1, 1, we need to give the proper input. So that can be done by the excitation table. Excitation table of the SR flip-flop. By checking the excitation table we can refer. Excitation table, what is the excitation table? That is output, present state and next state. We are deciding what is the input. Truth table means from input we are checking the output. From output we are deciding the input is called a excitation table. For example, present state is 0, next state also 0, mean what is the input we need to give. Similarly, present state is 0, next state is 1, mean what is the input required. That is the excitation table. So this is the SR flip-flop. 0, 0, present state, next state 0, mean we need to give the input as 0x. 0, S is 0, R is X. R X means 0 or 1. It may be 0 or 1. Suppose 0, 1 we need. Present state 0, next state 1, means the input what we need to give 1, 0. S is 1, R is 0. 1, 0. Present state is 1 and next state is 0, mean what we need to give 0, 1. S is 0, R is 1. Suppose both are 1. Present state also 1 and next state also 1, means what we need, means we need to give x into x and 0. S input is x, R input is 0. So based on this truth table we can fill this SR input. 0, 0. Both present state and next state 0, 0, mean what is the input? 0x. 1, 0. 1, 0 mean we need 0, 1. 0, 1. 0, 1 means 1, 0. 1, 1 means x0, right? So excitation table we filled the input for SR flip-flop. Now we need to find the logical expression for S and R by using the K-map. By using K-map we need to find the expression for S and R. Now we'll see the K-map. What is the K-map available for finding the expression of S and R? So this is the K-map available. First we will find the S for expression for S. So two inputs D and Qn. D and Qn. From that we can find the expression for S. D available vertically, Qn available horizontally. D one variable, two possibilities, 0, 1, D bar D. Qn one variable, two possibilities, 0, 1, Qn bar Qn. So from the truth table we filled these columns 0, 0, 1, X. So we can group these two cells. So correspondingly what is available in the row D? The corresponding column Qn bar Q1. So got cancelled. We need to refer first column and second column. Both are cancelled. Second row what is available? D. So the S input is D. So this is the K map for R. In this, these two cells are combined together. These two are 0. So correspondingly we refer the first row. First row is D bar. First column and second column Qn bar Qn. So got cancelled. So R input is D bar. From the truth table we frame the K map. From the K map we got the expression for S and R. S is D, R is D bar. Complement D, D bar. Right. So by using this we can go for the logic diagram. We can design the logic diagram for this conversion of SR flip-flop to D flip-flop. So this is the SR flip-flop. S input, R input and clock. Qn output, Qn bar complement of the output. So what is the S input? S input is nothing but D. We need to give S equal to D. So S is given with D. And R is nothing but D bar. So by connecting one NOT gate, D is converted into D bar, that is given to R. So S is connected with D and R is connected with D bar. So that this SR flip-flop will perform the operation of the D flip-flop because we are used this expression. Now we'll see the description is available. As shown in the diagram, actual input of flip-flops are S and R, where D is the external input. So for this flip-flop, S and R is the internal input, but external input is D. We design the D accordingly. We design the expression for S and R accordingly we given. The four combinations of S and R in terms of D and Qn, conversion table, logic diagram and K map are shown in the diagram. So in this video we discuss converting from SR flip-flop to D flip-flop. First we discuss the D flip-flop. What is the nature of the D flip-flop? For that, what is the input need to given to SR flip-flop? For that we refer the XR flip-flop excitation table. From the excitation table we fill the SR flip-flop inputs based on the D flip-flop. Then by using K map, the expression for S and R is identified from the K map and that is implemented with the logic diagram by using the SR flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.